Welcome to Automate 2024. We're here at the Festo booth, and we're going to show you guys some of the cool things that Festo has and some of the new products that they have launched. So yeah.
Thank you so much. My name is Sandro Quintero, and I'm really happy that you guys are here. So let's talk a little bit about what we have here at the show. So here you can see multiple axes. As you can see, X, Y, Z on one side, and then a pick and place application on the back. Basically what this is doing is just showing, picking that part that it's dropping right there, and then this system here, it's gonna simulate some dispensing, right? Yeah. Basically, if you think about it from a motion control standpoint, the one on the back is just doing point-to-point motion. Yeah. This one though is doing interpolation, right? Because you have to follow that path. Yep. The highlight here is that we're showing the new actuators, right? So these are new actuators that were released like less than 6 months ago. They were designed with better capacities for moments. Also, one of the other things I like to highlight, I don't know if you noticed this, but Festo motors, Festo actuators, Festo drives, and Festo motion controller. So everything is Festo, right? You might ask like, why? You know, like, can I put some other brand on a servo motor? Yes, you can. The reason why we usually recommend to put everything as a package is because, like, when you buy a 6-axis robot, right? You work a lot with FANUC, right? Yep. When you buy one of those robots, you don't say, sell me the robot without the motors because I use these other motors. That would be a nightmare for you, right? Right. What we do here is the same thing. This is just a gantry or cartesian robot.
One other thing that's really nice about just like doing the Festo servo type of systems is it gives you the ability to have like customization, right? You can, like you see right here, we have 2 axes here, we have a 3rd axis there, and just the configuration and the way that these are all mechanically mounted and how this is all fitting in this box. You know, this rail could be mounted further over if you needed a reach that was further and like, let's say the X direction or the Y direction, or you could, engineer this to be a longer unit to give you more travel distance.
That's a really good point. I've worked on projects where we've had 8-meter long actuators, right? And that one was, for example, for like a fabric extension, right? So that you would grab the fabric from a roll and then just extend it to a certain length. But you're totally right. You're hitting the nail on the head. The other thing, when you think about it from a safety perspective, if you look at this, everything is enclosed, and you touched on it, right? Yeah. When you're using a 6-axis robot, you would have to have a fence, right? Or maybe some safety scanners or something. But with this, because of the envelope of a cartesian robot, which is basically it's a cube, it's not like if you're using a 6-axis, it's usually like a kidney shape, right? Yeah. With this, everything is self-contained, so that's another benefit. Now, I gotta be clear though, each technology has its use, right? I'm not saying one is better than the other one. I always tell every engineer, utilize the right technology for the right thing. It's like tools, right? You wouldn't grab a hammer to drive a screw, right? You gotta use the right tools.
For a big use case for these type of systems is if you need to travel longer distances. I mean, one, you could pair it with a 6-axis robot. If you wanted to, you could just throw a FANUC on top of this rail and then be able to traverse that 6-axis robot across the way. And you could do that to transfer the part from like one location to another, or let's say, for instance, you had a SCARA robot.
Machine tending too,
yeah.
Right? You have a CNC, you're picking up a part, grabbing it, and then, dropping it in a bin or whatever, and then you put another part in, you close that CNC, and then you go to the next one.
And like what I was gonna say with like the SCARA robot, you could have that SCARA robot servicing one area. Maybe you need the high-speed motion of the SCARA robot, and then you can shift over a little bit, perform your next operation, or be able to shift on a recipe-dependent type of methodology. Maybe this part number you need to be further over in the X direction. Next part number you need to be further over in the Y direction, and you can do that manipulation for a longer distance by utilizing the rail.
Right. One of the beauties that I forgot to mention is when you're working with these servo systems, there's a software on the Festo website. I don't know if you've seen it before, but if you haven't, I recommend that you check it out. You go to festo.com/EMS, and that stands for electric motion sizing. Basically there, you would put the parameters for your application, just like the ones that you were talking about. Length or stroke, payload, and maybe like cycle time. And that will give you a set of combinations that you can use. Now, here's the beauty though, and I know that you're into programming too, so you're gonna understand the beauty of this. From there, once you pick your system, there's an option there that says download commissioning file. You download that file and you put it into the servo drive software, everything that you sized on the mechanical side comes already into the software. So you don't have to tune the motors, right? You know that pain. You know, it can take 3 hours or something. You know, if you're this, you can do it in 10 minutes.
Yeah, you have to go through and plug it in all the parameters of each servo.
Exactly.
How long.
All of that is done.
Yeah.
All of that is done. It includes, you know, the payload, the stroke. This is a big thing. I've been talking to controls engineer about it, and when I talk about it just like now, you're like, that sounds interesting. But when they see it, they're like, holy smokes, like that is cool, you know?
Yeah, absolutely. Yeah, I mean that type of ecosystem is like what really makes like companies like ours be able to like become profitable. You know, we're able to implement the technologies that allow us to deploy the system faster and more efficiently.
You're not in the business of tuning servo drives. You're in the business of building machines.
Yep.
And what's your slogan? You have a slogan of
freeing humans one robot at a time.
Exactly. Yeah. That's what we're doing. So that's in a nutshell. I guess one thing that we didn't mention about the control side, codices. So we're using codices on this. You're familiar with codices. And the servo drives that we have in here, they're multi-protocol, meaning that you can do Profinet, Ethernet IP, EtherCAT, and Modbus TCP on the same drive, one part number.
And so going back into like some of the differences between the older servo drives and these newer servo drives, what again are some of the benefits of these newer ones?
With the same form factor, you can have higher loads. This has a dual bearing guide internally, so it was designed in a way that it could withstand more payload. That's one of the highest or the biggest things.
Gotcha. So mechanically, you have two.
Yeah. So you can actually see them in here.
Okay.
There's one on this side, and then on the other, it's just like a cutaway, right? But there's two or one on each side, so you have a better support.